How many people say the answer is A? Raise your hand. B, C, or D? Okay, so we see most of us think it's B. So let's look. If we're doing Q, R equals, so this would be like our Y. Q, that's like our X every time, right? So we're going to take the Q plus 10.1. So right away, you can see that that's not adding, right? This looks like it's plus 10.1. What about this? That's like plus 5. And then this one, so that looks good so far. So now what we have to do? Just keep doing it, right? So plus 10, no, that's not plus 10. So B was the correct answer. Okay. Any questions from homework? Okay, so let's see if we could figure this stuff out. An algebraic relationship whose graph is a line is considered a, what do you put there? What kind of relationship? Linear, because it's a line. Very good. The input value, or our x value, is defined as independent. And your clue is in the word input. Remember that IN in the beginning is independent. It's what we put in. Versus the output, or our y value, is defined as our dependent quantity. Okay? Okay. It says, think of our inputs and outputs as a factory. What can we do to the x to get the y? This is how we come up with our rule. Our rule now translates over to our equation. So your x is always going to be in. Your rule is what you do to get y. So your out is going to be your y. Okay? So far, in all of our days of doing this, we've been doing a lot of telling you what is happening, or you have been applying, like yesterday, right? Now I'm going to give it to you, and you have to figure out what is it. Okay? So kind of thinking back to the first day. It says, write an equation to represent the relationship between the independent and dependent quantities shown in the table. Y'all, independent, what's the letter for independent? No, the letter, X or Y? X, and versus dependent is Y. Okay, so that's all they're asking you. So we're back to looking at the table. 1 to 9, 2 to 18, 3 to 27. What's happening? Say again? Times 9. So like our rule is times 9, but when we write an equation, we need it in terms of x and y. So what would you say? 9x. There we go. I heard it. Remember, we talked about different ways to write that, x times 9, but we want to write it as 9x. Okay, so now on our table, it just says it sometimes helps you to put it in your own table. You can, meaning if you took the 1, 2, 3, 4, and 5, and you did 9 times 1, you get 9. If you get 9 times 2, that's 18. Okay? You don't necessarily have to do this if you were able to do it from that one. Okay? This is just there if you need to. Does everybody understand? Okay. How about you guys try the next one? You guys try number 2 on your own. Okay, so just like on the last one, you start by going, okay, 1 to 16. Well, there's 2 ways I can get there, right? I could either plus 15 or times 16. So it's either plus 15 or times 16. So in order to know if that's true or not, I have to do what? I got to go again. And I'm like, okay, 2 plus 15 is not 32, so it's not that. But 2 times 16 is 32. So then that proves that the equation is y equals 16x. Okay? Again, this is here if you need it. You don't have to do it if you don't want to do it. But if you did, It's just a place for you to put the work. That's all it is. It's just a place to spread it out. Okay? Okay. I wanted to do this last one together. It says the average person uses about 12 gallons of water each day for showering. Complete the table to show the relationship between the number of gallons a person uses, or G, for showering and days D. Then determine how many gallons a person uses showering each week. Okay, so two different things going on here. First, we have to figure out our equation, and second, we need to know how many gallons after a week. Okay, so it says 12 gallons of water per day. So that means on the first day, how many gallons will they have used? 12. So I can fill that in right here, right? So then on the second day, how many gallons will they have used? 24. And guys, how are you getting that? Well, you're doing, I was just going to say, you just told me plus 12 right there, but we know when we make an equation, we're supposed to go from our input to our output, okay? So I don't want to do that. How am I getting from input to output? Times 12. Okay, so we can finish filling this in. 36, what would 4 be? 48. So then why did they put a D there? What's that for? Exactly. It's saying for any number of days, what are you going to do? Times 12. So what should go in this box? 12, not X, but what is our variable? D, right? See the days is D? So it would be 12D would go right there. Okay? So now we're writing our equation. And they want it in terms of G and D. That's why they gave you that. So what would you put? G equals 12D. What if I asked you to do it in terms of Y or X? Y equals 12X. So here's the thing, you guys. Our brains, because we've been doing this for days with X and Y, how many of you automatically went to X and Y in your brain? Great. There's nothing wrong with that. Here's how you fix it, or how you help it. Then over here, you put an X and a Y for your input and your output. That way you don't get confused. And when you knew that it was Y equals 12X, you're going to replace your Y with G, and you're going to replace your X with D, and keep everything else the same. See what I'm saying? That way you don't get confused with other letters. It means exactly the same thing. We've been talking about Y and X because those are good for everything. It's just in this particular problem, they came in here and said, I want you to use these letters. So if this was a multiple choice test, or think about those questions yesterday, where they had W and I can't remember Q and R. Remember, you just gotta know how to do it with all the letters. Okay? Okay, so the second half of this question, we did the equation, check. The second part says, how many gallons do they use in a week? Well, what do we have to know about a week? That is equal to 7 days. So that means G equals 12D. You want to write down your equation. But now, 7 days. What's going to get replaced in my equation? The G or the D? The D, because it's days. I'm replacing days. So I want G equals, please stop that, 12 times 7. And what is 12 times 7? 84. 84 gallons. Remember, it's total gallons after a week. Okay, we could have gotten that same answer had we continued this table all the way 5, 6, 7. But you just want to know how to do it without it. Okay, any questions about that? Okay, let's go on. All right. Before we get started with the notes, I have a turn and talk, right? What kind of relationships will each of these graphs represent before we do any kind of work? I'm just saying, I want you to look at the graphs and decide, is it going to be additive or multiplicative just from looking at the graphs, okay? All right, super quick. The first first one, do we think that this is additive or multiplicative? Multiplicative, why? Because it's a straight line and it's going through the origin. Multiplicative. Let's talk about this one. What do you think?
Additive.
And why is it additive? Because it's not at the origin, it's up here, but it is still making a straight line. Very good. And how about this last one? Multiplicative because it's a straight line. It is going through the origin. And before we even get started, what do you notice about this graph that's been different than every other graph we've looked at? It's going down. Okay, so this is a little bit different. Okay? All right, good job. All right, so let's see what it's asking us to do. It says, we can also find our equation from a graph. Remember when graphing that our x value is our independent and our y value is our dependent. So let's try looking at one of the graphs, okay? So first of all, I would put down here that this is our independent, which is our x. This is our dependent, or y, okay? My advice is to pick at least 2 or 3 points off of the graph. And when you pick a point, remember you want to pick it right on the crossbar. What I mean is, here's one that's on a crossbar. But see, I don't know about this one. It's kind of in the middle. But I would pick this one, see, because it's right on those crossbars. You guys see what I'm saying? Okay. These other ones might work out okay, but I'm always hesitant to pick something like that. So that means 0, 0 was the first point. Can I learn anything from just using 0, 0? No. I gotta use this one. So that means my x is 4. And what is my y? 2. 2. Okay? So the points were 0, 0, and then 4, 2. I'm hesitant to use just that other one because who can tell me why? Why isn't it reliable? Well, tell me how I can get from 4 to 2. Divide by 2. How else can I get from 4 to 2? See? So I'm like, well, but yeah. So I don't know. I say let's try to pick this one up. What do we think this is? Or this one. What does it look like? What's this one? 2, 1. And then this one, 6, 3. So while those would not have been my first choice, I really think that I need them because now I can definitely see how am I getting from 2 to 1 or from 6 to 3. How are you getting there? Divide by 2. So because I know I'm going to divide by 2, now I have to think about how to write that as a process. Because remember we said we can't write divide by 2. There's another way to write it. How?
X over 2.
Yes, I can do x over 2 or 1/2 x. Remember that? As either one, as a fraction. Okay? So then just double check it and make sure that it's true. 0 divided by 2 is 0. 4 divided by 2 is 2. 2 divided by 2 is 1. 6 divided by 3 is, divided by 2 is 3. Okay, and it was true. So now that I've done all of that, now up here I want to write my equation. Y equals x over 2. Will that work? Or what else can I write? I even could write y equals 0.5x. Would that work? Have worked as well? Would that be the same thing? Sure. All right. Why would you do that? Sounds like making it harder. Yeah. Okay, let's look at the next one. Or do you guys? It says let's try it on your own. Y'all want to try this one on your own, or show me? Okay, try it on your own. Go ahead, try it on your own. Okay, so if you were like me, I started by picking my points at 0, 2. I picked this one, this one, this one, and then I decided to just skip some and just make sure that it would still be true along the way. So how are we getting from 0 to 2?
Plus 2.
And 1 to 3. It's plus 2, right? That's our process, it's plus 2, so let's just double check it.
You got the wrong. You didn't put me on it for.
Just kidding, so it's supposed to be what, 3, 5? Thank you. Sorry, 3, 5, say thank you. No, I meant to skip. See, I was trying to skip that one. Oh, this one. I see what you're saying. So then plus 2. So then 1 plus 2 is 3. 3 plus 2 is 5. 6 plus 2 is 8. Very good. So now, what would we write for our equation? Very good. And this proves what you told me a second ago was you said it was going to be additive because it was straight and it didn't go through the origin. And then look, see, we got an additive equation. See, it's just kind of double checking ourselves, all right? Okay, do you guys want to try the next one by yourself again? Try that one on your own? Okay, you guys. So, can I tell anything from 0, 0? I can't tell anything, so I gotta go to the next one. 2 to -4. 3 to -6, and 5 to -10. What are we doing every time? Are we? We're multiplying, right? Okay, by what? Oh, by -2, because 2 times -2 is -4, and 3 times -2 is -6, and 5 times -2 is -10. So yes, it would be true here as well. So we know that our the rule is what? Times -2, right? Or -2x is another way to write it. And what's the equation? Okay, if I write x -2, what does that look like? That looks like subtraction, so I don't want that. No. Okay, don't make it quite too hard. What if it was just times 2? Well, then what would you write? Y equals 2x. Okay, so if it's -2, there you go, -2x. I wasn't trying to be hard. -2x. It just means -2 times every x value. Okay, and no x equals. Remember that all equations have to start with y on the linear equations. Okay, so let's say that y equals x -2. Is this okay?
Yeah.
Technically, it means the same thing, but it's kind of like saying I ain't going to the store versus I'm not going to the store. We want to speak correctly, not like in slang. And while this does give you the same value, this one is better. Okay? And again, when you started, you told me this graph was going down. I want you to take a look and tell me, what do you think it is about this graph that's making it go down? What is it that's different, y'all, about this equation that's now making it go downward? The negative, that's exactly right. Guys, right here, the fact that we were multiplying by a negative in the beginning is telling you that we're going to be going down. Okay, just something I wanted to point out. Okay, I think you guys are ready to try these on your own. So, if you look the next 2 pages, looks like a lot. I don't want you to do all of them, just the odds. Just the odds, okay? And then we will check.